Hi everybody, today we will be discussing the 2019 AP Chemistry question number 3, which deals with ions in solution and acid-base equilibrium. This first question is simply asking us to write an ionic equation. When looking at the species, we see that both the sodium cation and the nitrate anion stay in solution, so those are our spectator ions, leaving only the calcium cation and the carbonate anions, so we balance with only those ions, making sure to put our charges on. The question specifically stated that an excess of calcium nitrate was put into solution, but we don't see any excess calcium ions, only nitrate and sodium, so we need to put in some calcium ions, but we also need to balance the charges. Since there are 2 more nitrates than sodium, there is a -2 charge overall, so we can put 1 calcium 2+ ion in. This question is just some simple stoichiometry. Take the mass, divide by the molar mass, and get your answer, 0.0093 moles of calcium carbonate. And since the reaction had coefficients of 1, it's also 0.0093 moles of sodium carbonate. In this question, we have to think about what happens when there's extra water and put that thought process into our answer. More water means extra mass, which means that you calculate more moles of sodium carbonate than you actually have, causing the molarity to be too high, so you have to disagree with this student. This question is answered by question 3b. You really just have to mention that since there are ions in the solution still, the solution will conduct electricity. This one is simple. Since we can't use titration, the student could just use a pH meter to find the pH of the solution. Here, we don't even have to do any calculations. We just have to explain that the student would do 14 minus the pH to determine the pOH, and then put that to the -10th power to determine the OH concentration. Then, the student would substitute into the Kb expression. Remember that the concentration of OH is equal to the concentration of HCO3, and solve for the concentration he's looking for because we already have the Kb. When we look at the Kb, it is less than 1, so we know that the reactants are favored, so there's more reactant or carbonate ion than there is product or bicarbonate ion. For this question, we have to answer no, because if we divide the Kb by 1 times 10 to the -14 to get the Ka, we find that the Kb is higher, so base formation is favored over acid production, making ideal buffers basic, so we can't make an acidic pH buffer. That's really it. I hope this video helped y'all, and I hope that y'all will join me next week. Take care, y'all, and I'll see y'all in the next one.